In the previous video, I discussed the theory of how a lightning rod works, namely that a small radius tip can't hold a lot of charge before that charge simply leaks away instead of becoming a damaging lightning bolt. We're going to use this cool vintage Dodd & Struthers lightning rod, which I believe comes from the early 20th century. It was in the storeroom at Manchester High School. We're going to hold it up to our Van de Graaff generator, and we're going to use this to demonstrate how it's not able to hold large amounts of charge before discharge happens. Alright, so we watch as I bring the sphere on the end of the discharge wand. You can see how close I can get before we get a lightning bolt. We can see a similar result as I bring my hand close. That's how close I can get my hand. But watch how close I can get the lightning rod. I'm hearing it discharging. There's little tiny bit of light that I can see, but you probably can't. But I can get this super close without a large discharge. Again, it's because the lightning rod tip can't hold large amounts of charge. I want to look at a part of the Van de Graaff that often gets overlooked, and that is the discharge wand. And it's very important how it's set up. If you look, there's a wire coming off of it, which is actually clipped to the base of the generator, which is a conductor. It's made of metal. And that metal case, and therefore the wand, are actually hooked up to the earth itself through the power cord. If we go over and look at the plug-in, we can see that there's 3 pins. And the 2 flat pins are the ones that actually provide the electricity. The round pin is called the grounding pin, and it goes out through the wiring of the school, and it goes to a pipe that's sunk into the earth somewhere. The point of this is that the earth has lots and lots of electrons. And that means electrons can come up this wire, and they can go to the base of the Van de Graaff and the wand. Or if there's too many on there, they can leave. And that's going to help us understand how the wand can actually cause lightning bolts near the Van de Graaff. You can understand why the lightning rod acted so different than my hand or than the discharge wand by watching the previous video where I explained how lightning rods leak charge. But there's one thing that may be confusing. It's not clear how the lightning rod or the discharge wand was getting charged. Obviously the Van de Graaff was, but what was happening with the rod and the wand? Let's start with the wand. Because it's wired to the earth, as I just showed you through the plug-in, it can have the earth's electrons if it needs them. And the earth's electrons are noticing that they have a path up that wire towards the Van de Graaff. And into this wand. And they like that because that gets them closer to a positive charge. So in other words, the running Van de Graaff induces a negative charge in the wand. And that induced negative charge can be fairly large in the spherical shaped wand. It can't be so large in the pointy lightning rod. I'm not hooked up to the earth, but I still do have a lot of electrons. And they get drawn to the tip of that lightning rod through me. And we get a lightning discharge, or a leaking of charge, much sooner because the lightning rod had a pointed tip. Here enough charge could build up that eventually we had a large lightning bolt. So it's the same physics as we talked about in the lightning rod video. It's just that the charge that's building up on the objects is an induced charge due to the large positive charge on the Van de Graaff.